Okay, the next question, there's no real life context here. It's purely a sort of theoretical question with numbers and symbols in it. We've got an A probability, a B probability, a union probability, and the first thing we want is an intersection probability. So, somebody who hasn't already told me today what the formula to use here, what is the formula to use here that links A, B, their union and their intersection together? Somebody who hasn't said it already today, what is the formula that links them together?
PAUB equals...
Hang on. A union B. Yep.
Probability A plus probability B minus probability A and B.
Yeah, that's right, okay. That needs to be in everybody's heads, okay? You will need to use this quite a lot. That's the formula we had last time. We need to use that. So for part A now, just stick the numbers in you know. So probability of A, 0.7. Probability of B, 0.4. The union, 0.8. And we're just left with this intersection over here. So I've got 0.8 is 1.1. Take away something. Okay. What do I have to take away from 1.1 to get 0.8? 0.3. So, just straight using that formula, we can get that first answer. We now know that is 0.3. Now, the next thing is this A vertical line B. Can anybody tell me, again, we looked at this last lesson or the lesson before, how I read that out and what that means? How do I read that out with that vertical line between them?
Probability of A given that B.
Yeah, exactly, that's right, yeah. The probability of A given B. So it means what is the probability that A will happen given B has already happened? That's what that means. Good. Can anybody either look back in the notes or tell me from memory what the formula is to deal with this? It's another formula that you need to just know eventually. It should be in your notes as you want to look back. But you have a formula for conditional probability. These formulas, if you haven't got them highlighted in your notes in colour, even as you do them now, I suggest you do that because you need to know them. Can anybody find it and tell me what this is? Lucy, have you got it? Okay. Maybe from the lesson you missed. Can anybody tell me what this one is, the conditional probability formula? It would be great if I sort of went around and I could see some people who've got good use of colour in their notes. They can instantly find the important things. Go on, Leon.
E bracket A N B over D.
Yeah, that's right. Okay. If you're one of the people who hasn't got that highlighted and you've got a coloured pen or something, even if you've written it down now, highlight it at this point because it's something you need to be able to find. Okay? Now here's a highlighting pen. Who's the first person to claim the highlighting pen? Okay? And just pass it around and bring it back to me in a minute, okay? So that's the formula for conditional probability. So, do we know what the probability of A intersection B is? Yeah, we just worked it out. That's 0.3. Do we know what the probability of B is? Yeah, it's given to us in the question, 0.4. That's the same as 3 divided by 4, the same as 3/4, so that's going to be 0.75. Part C looks very similar. It's just the letters over here are swapped around. It's the probability of B given A. So all we need to do now is just basically swap the letters around in the formula we had last time. So, what am I going to write on the top line here?
A and B.
Sorry?
A and B.
Yes, but I'm not going to for a minute. You are right, okay? Because it's this one and that one. I just want to sort of labour this point in a minute. It's that one and that one. Then on the bottom, it's the one after the line. Now, B and A, what is B and A the same as?
A and B.
A and B, yeah, okay. I just wanted to emphasise that point. B and A and B are the same thing. The same way that A union B and B union A are the same thing. The order you write them down doesn't matter. So A and B, we already know, we have it here, that's 0.3. A was given to us in the question, it was 0.7. You can then work that out on a calculator if you want to. It's 0.429, I'll tell you that one, 0.429. The final one is another conditional probability. It's probability A line B dash. So can anybody tell me how I would read that one out? What is that one if you were reading that out? Will, could you have a go at saying what that is?
The probability that it will be A if it's not B.
Yeah. What's the probability of A given B has not happened? Yeah. Okay. So using the formula, it's on the top the first one and the second one, and on the bottom it's always the second one. Okay. Do we know, have we got written down anywhere the A and not B probability? No. Okay. So we're going to do a little bit of extra work here. Can anybody think of a way, a technique we've used before that would maybe help us to work out these probabilities here?
One take away the probability of it not being B.
Well, this one down here, not B, is one take away B. Yeah, okay. What I would suggest you do at this point is a Venn diagram just to help you, because you know virtually everything. You've got two things. You've got A and you've got B. Let's just work out what we need. If you're doing a Venn diagram, which is the most useful section to fill in first?
The middle.
The middle. This is A and B. Do we know what the middle A and B is?
0.3.
0.3 is this answer up here. That's 3. We know all of A from the question is 0.7. All of A is 0.7. So what's this bit on the left? 0.4, yeah, because 4 and 3 make 7. We know all of B from the question is 0.4. So what's this bit here? 0.1. Everything we've written down so far adds up to 0.8. So that means what is left? 0.2, so that's outside somewhere. So, first of all, if I want to look at A and not B, can anybody tell me what is, from looking at that, A and not B? It's got to be in A, and at the same time it mustn't be in B.
1.4.
Yeah, okay. It is, and I'm just going to shade it in here just to sort of make it clear. It's that green shaded area there. Okay? And if you do the Venn diagram, it is much easier, I think, to work out what some of these complicated areas are. So that is 0.4. So just working down from that line up there, the top line of my fraction is 0.4. Not B, from what Tabby said earlier, is just 1 minus the probability of B. So B was 0.4. So 1 minus 0.4 is 0.6. 4 over 6, 2/3. There's a decimal 0.6 recurring. So that's an example of a question where there's no context, no real life stuff, purely theoretical. Basically it's testing, do you know the formulae? Can you manipulate the formulae? Can you do the Venn diagrams to work out missing bits?